Okay, so hopefully you took about 10 or so minutes to complete the first two questions. If you guys need a little bit more time, that's totally fine. Just pause this video until everybody's done. Don't take too much time because, again, the test is not going to be just two questions, so you need to be pacing yourself and getting these done. But if you need a little bit more time, pause, and if you are ready to go, then we'll get started. Okay. So the first question says to fill out the specified information to state the possible rational zeros and find the rest of them, okay? So how many solutions is this going to have? This little exponent of 3 tells me 3, okay? The highest exponent, the degree, tells me how many answers. Possible values of p. So again, p is the constant. So I'm looking at this back number right here. The factors that go into 4 would be 1, 2, and 4. That's it. Okay. Then we're dealing with the factors of q, which is going to be that leading number, that leading coefficient, which is 2. Only thing that goes into 2 is 1 and 2. Okay. So now we're just simplifying this fraction here to tell what are my possibilities. We start with our first numerator, which we said is 1 over 1. Gives me the possibilities of 1 and -1. Okay. Move on to our second denominator, still keeping that 1 on top. We could also have 1 and 2. So 1 over 2, which would be 1/2 or -1/2. Okay. Then we could also have this 2 over 1, which is going to give me 2 or -2. 2 over 2, which would give me, to simplify, 1 and -1 again, so I don't need to rewrite those. There's absolutely no point, okay? If you did, you're not wrong. Just know that you don't need to try those again. They're just one number. And then we have our last numerator, 4 over 1, so that's going to give me 4 or -4, and then 4 over 2, which is going to give me 2 or -2, which, again, I already have, so I don't need to write them again, okay? So these are all my possibilities. There's only 8. I say only, that's quite a few, but we know that only 3 answers total, so obviously all 8 of these are not going to work, okay? So we've got to start testing them. We'll start with the first one, which is 1. We'll do synthetic division, put my numbers going across, so we got 2, -1, -8, and 4. And we start testing these, so we drop down the 2. 2 times 1 is 2. Add these up. 1. 1 times 1. 1. Add these up. Multiply. -7. Add these up. Okay. So I end up with a -3. Not going to work for me. Okay. I needed that to be a remainder of 0, and it's not. So 1's not going to work. We move on to -1. Put the same numbers going across. And we keep going. Drop down the 2. 2 times -1. -2, -3, 3, add them up, -5, 5, add them up. Oop, not going to work, dang it. Moving on, 1/2. Up in my ledge, same numbers, 2, -1, -8, and 4. Drop it down, 2 times 1/2 is 1, add these up. 0 times 1/2 is 0, add these up, and -8 times 1/2 is -4, giving me a remainder of 0. Awesome, awesome, awesome. This one checks out. X equals 1/2. Go ahead and box that in. That's your first answer. Perfect. Which then leaves me with a polynomial in disguise. So working from the left, the 0 is the remainder. I don't need that. The -8 would be the constant. The 0 would have an x on it. I don't need to write 0x. And then the 2 would have to have an x squared. Set it equal to 0 and solve it. Okay, so looking at this, 2x squared and -8 both have a 2. Take that out. Oops. Okay, and we keep factoring. So we got a 2 out front. X squared minus 4, hopefully that pattern looks familiar to you. It should. Anytime we have a binomial with an exponent of 2, subtraction sign, and both of these terms are perfect squares, we have difference of squares. So A is x, B is 2. We end up with x minus 2, x plus 2 in whichever order. equals 0. Okay? And then we break apart our factors, set them all equal to 0. 2 equals 0, x minus 2 equals 0, x plus 2 equals 0. Okay? Can 2 actually equal 0? No, so that's not actually a factor. There's no x's there. But x can be 2, and x can be negative 2 when I solve those. So I have a total of 1, 2, 3 answers, which is what I wanted. So those are my answers there. I did have to do a little bit of work, okay? So that's going to happen on these. So make sure we understand that process, and if we don't, we are coming to get the help that we need. Okay, next one, sketch a graph that meets the given criteria. So this is what we did last class with our sketches, okay? A and B are going to tell me how this begins and ends, right? That end behavior. So left and right. Where are my arrows going? So if it's an even degree, I know that. That means I'm either both sides are going up to infinity or both sides are going down to infinity. We're ending the same way. And then the leading coefficient being negative, well, that tells me both are going down. So arrow pointing down, arrow pointing down. Done with that. Now I just have 3 real roots. It tells me exactly where these go. 0, 2, and 4. So that's where I put my points on my x-axis. Perfect, easy enough. And then I look at my multiplicity. So if it's an even multiplicity, it's a bounce. If it's odd, it's a through. So this means through, this means bounce, and this means through. And we start from the left, move to the right. So the first one I'm going to see is 0. So I take my arrow from the left. I know I've got to go through 0. Okay, and I'm going to bounce on 2, bounce, and I'm going through 4, ending at the bottom. Okay, not perfect, not the most beautiful graph we've ever seen, but you should have had a similar picture. Okay, awesome. Hopefully those made a lot of sense. Those will be on your final, so make sure you're good on doing those. Okay, we are pivoting a little bit. Okay, this is not the 3.9 that is in your notes packet. This is 3.9 that I've changed a little bit and that we're going to be working off of. So how this is going to work is this is going to give you a polynomial graph. It's already graphed for you, so the hard part's done. And you just have to answer the questions about it, which shouldn't be too hard because we've talked about all of these things already. Okay, the first thing though it says is function. We don't need to worry about that. That's not on your test. Okay, so I'm not worried about that blank, but I am worried about the degree. Okay, this means the highest exponent, right? That's what degree means. Degree also means the amount of answers that I have, okay? Remember, though, that the degree is going to total, so total answers. You need to consider not only your multiplicity, which are even amount of answers at the same root, okay? You also need to consider your imaginary. So remember, those imaginary are going to be those little bumps that are up or above our axis or down below it, but not on the axis, okay? So if I look here, this thing looks pretty smooth. I don't see any like random bumps up or above or below, so this is not going to have any imaginary, so I don't have to worry about that. Perfect, okay? Then I want to look at all of my roots here. I see 1, 2, 3, okay? And is this graph going through or is it bouncing at those points? And if I look, we are crossing. We're going through, okay? So my degree here is just going to be 3. I have 3 answers here I'm dealing with. Odd amount of answers, which makes sense because my ends are going opposite directions. Odd means opposite, okay? So that's perfect. 3 is my degree. Then we move on to domain. This is left to right. So this thing, it's got arrows on it. It is going negative infinity, positive infinity. Left forever, right forever. Same thing with range, bottom to top. This thing's going down forever, and it's going up forever. So that's pretty easy. Not all of them are going to do that, okay? But if they're opposites, if they're odd functions, they are, okay? Then we deal with our limits. We know we just copy our domains down, and then we see as x goes to the left forever, what is y doing? Well, as x goes left forever, I can see that y is going up. So we call that positive infinity, okay? And then as x goes right forever, I can see that y is going down. We call that negative infinity. Perfect. Then we get into our maxes and mins. Okay, so these points are already illustrated for me, so I don't have to guess at where these points are, but I just need to find what are my high points and what are my low points. Okay, so we'll start with maximums. That's the first blank. We've got to find, again, the highest turning points, and it looks like right there is going to be my only max that I'm dealing with. So I'm just going to write that point down. No math at all, just copying. And then we move on to our mins. So these are turning points that make low points. Looks to me like we just have one. Easy enough, write it down. Perfect. Then we get into our increasing, decreasing intervals. Okay, I know this is everyone's favorite. If you can sense the sarcasm in my voice, it is there, okay? These are the roller coaster things, okay? So as this goes from the left to the right, what is this roller coaster doing? This one kind of looks like it would be a little bit fun if it was at Six Flags, right? It's going to go down, it's going to go up, and it's going to go down again, okay? Which tells me down, up, down. I'm going to have 2 decreasing intervals, 1 increasing interval, okay? And we know that we've got to show on X, the pathway on X where this is happening. Okay, so when I'm talking intervals and all of those points where I'm changing direction, I'm talking about right here, and that's it. Those are my only 2 direction points. Okay, so from negative infinity to negative 1.12, bam, I'm going down. So negative infinity to negative 1.12 is my first decreasing. Okay, this is kind of getting sloppy on me. I'm sorry, I'm not a good artist. So right there, that's my first decreasing. Then as you can see, I start to change direction. I'm now increasing. And again, it's from those X values. So from negative 1.12 to 1.786, which I found right here. Okay. And then we're switching direction again. So from 1.786, we're going down to positive infinity because, again, it's X values. So to the right forever is positive infinity. To the right forever, not down forever. That's not what this is asking. It's asking where on X is the pathway, which is why to the right forever is positive infinity. A little confusing, I know, but we'll practice this more as we go. Okay, and then lastly, X and Y intercepts. This should be the easiest one. Okay, they're given to me plain and clear. Okay, so if I look, X intercepts really easy, negative 2, 0, 0, 0, 3, 0, Y intercepts 0, 0, and that's it. Okay, so take a minute if you need to pause this to write all this down, ask questions to your neighbor, please do so. Okay, again, not doing functions, so cross that off, but here we go. I want you to just go ahead and try this one. Okay, write in pencil because you might be wrong, and that's okay because we're just starting out on these. So write in pencil, have the substitute, pause the video here, and I want you to try all of these. Work with the people around you. Okay, so one thing we should notice here, these are not opposites, okay? They're going the same direction as far as what our Y's are doing. So this degree needs to be an even number, okay? And if we look here, it looks though like I'm only crossing or I'm only touching that x-axis 1, 2, 3 times, okay, which can be a little misleading. So we know our degree has to be an even number because they're ending the same direction, okay? But if we look, we've got a through, which tells me 1, 2 answers there. And then we have this little guy. Call that a bounce, okay? We know that anytime we bounce, that means we have an even amount of answers, okay? And just because we're trying to keep this as simple as possible, we'll just assume that it's 2 answers there, okay? Which tells me 1, 2, 3, 4 degree. 4 is my degree. Even number because we are ending the same way. okay, through, bounce. So that's how I got that 4. Perfect. Okay, domain, left and right forever. That should be easy. Okay, then we're dealing with the range. Okay, so the range deals with bottom to top. Okay, these are going the same direction. So it's not, if we look, it's going up forever, but it's not going down forever. It is starting right here. Okay, and since range deals with y values, I just need this y value, negative 9.915, to positive infinity. That's how I get my range. Okay, limits, we copy our domain here for the x's, and then for y's, I just want to look. Well, we said that they're both going the same direction. They're both going to positive infinity. So whether I move left or right, I'm still going to positive infinity. Perfect. Okay. Then we're going to deal with our relative extrema. So our maxes and our mins, these are turning points only. Okay, remember infinity, negative infinity, those are not max and mins. Okay, they've got to be turning points. So if we look here, we just want to, let's just circle these turning points that we see. So I see one right here, obviously, right here, and another one right here. Okay, so for the max, we can see that there's only one peak point, one high point. Okay, and if we look there, it is just the point. All those points are kind of a little bit too close for me, but it looks like it's going to be the negative 0.219, 3.227. Okay. Perfect, because we can see that negative 1, 0 has to go with this point, and 1, 0 has to go with this point. Okay, perfect. All right, and then now we are dealing with our minimum point. So again, turning points only. So this negative 1, 0 point, that's not a turning point. Okay, I'm going through that point, so I'm not turning direction right there. So that can't be a minimum. So don't get that confused. It's just going to be these two turning points. So obviously the lower one is negative 2.281, negative 9.915. If that's the only one you put, that's fine, because technically that is the minimum. But technically we're just talking relative minimums. So really a lot of textbooks are going to tell you that this is also a minimum. So if you put that, great. If you didn't and you just put the lowest one, I'm okay with that. Okay, but technically it would be both, just because they're both low turning points. Okay, and then we get to our fun stuff, this roller coaster thing. Okay, so we want to just trace this as if it were a roller coaster and see what this thing is going to do. So looks like we are dropping down. It's a big drop. Okay, so we know, again, this is x pathway here. So from negative infinity to this x value, we are dropping, so we are decreasing. Perfect. Okay, turn in that roller coaster around there at that turning point. We are now going to be increasing from that same x value to this point up here, which we said again was this x value. So we've got increasing negative from where we left off, negative 2.281 to negative 0.219. Then we look at the roller coaster. We're back to decreasing here. Okay, so picking right back up where we left off at negative 0.219, and we are going to the 0.10, so I just need the x value, which is 1. Okay, and then again, with the roller coaster so long, picking back up from 1 and going to infinity, whoa, because that's right forever. So 1 to infinity would be increasing. So that one had 4. Okay. And then last but not least, x and y intercepts. So these are pretty clear to me. Okay, we got negative 3, 0, easy, 1, 0, negative 1, 0. Okay. And this actually did not give me a y-intercept, okay? Because this right here, doesn't have a y value of 0. So it's gonna have one, but it just didn't give it to me. So whatever, I'll just leave it blank. Okay, that's it. That is all for that. Okay, last one. Go ahead and try the one on the next page. Pause it for however long we need, work with your group, and we'll go over it. Okay, last one. Again, we don't need function. Degree here, okay? Ending the same direction. They're both ending down. What does that tell you right there? This has got to be an even number, okay? So if we look, we've got a through, so that means 1. We got a bounce here. You can see that bounce, that means 2 answers, so 1 plus 2 is 3. And then we got another through, which gives me 4. We'll go with 4. Okay, domain, left forever, right forever. Range, bottom to top. So this is actually going to start by going down forever. It's going to end at this y value of 2.833. Perfect. Limits, copy down our infinities, negative and positive. And then we said these are both going down forever. Whether I go left or right, I'm going down forever. So that's where y is going. Okay, max and mins, we should be getting pretty good at these. So if we look, technically we've got a max. This is definitely your highest max here, but we do have another one right here. So if you used both of them, perfect. If you just use the highest one, I don't care. Okay, so the highest one would be 1.443, 2.833. And then the other one, if you included it, negative 0.693, 0.397. Cool. And then minimums, again, only turning points. So this right here, not a turning point. This right here, not a turning point. This guy, absolutely a turning point. Cool. Increasing, decreasing. Here we go. The exciting stuff. So watch this roller coaster. We start by going up. Again, it's the x pathway. So negative infinity to this x value right here is going to be increasing. Then we look at our roller coaster. We're decreasing. We got a short little dip there. And that is from, again, that x value that we left off at, -1 to 0. Pick back up on the roller coaster, increasing from 0 where we left off to this x value right here, 1.443. And last but not least, this roller coaster is ending by going down. So picking up where we left off at 1.443 to positive infinity, because again, it's right forever, x pathway here. Okay, x and y intercepts. So we can see -1, 0, 0, 0, 2, 0. I'm getting a little sloppy, I'm sorry. And then y-intercept, 0, 0. Okay, that is it. It's a lot. Okay, so go back, look at these notes as you do your homework, and please, please, please be asking questions if you have them. Thanks, guys.